To start off, I'm going to show you all some cool machine learning stuff, so I need some volunteers. I need one to start, preferably someone with a beard. So, you've got a beard, I need you. So this is an experiment that Google have done for us, very helpfully. And this is machine learning in the browser, so what's your name?
Phil.
Phil, nice to meet you. Come across here. If you stand in front of my camera, I'm going to train a predictive model.
Where is it?
Here, it's here, sorry.
Okay.
I'm going to train this thing to, go on, try and get really close. Try and get your beard in there. I'm going to train this to play the sound of birds when you're in the camera. And all I've got to do is take some snapshots while you're in there. Now, because you're in the camera, it's playing the noise of birds. If you step out of the camera, all we've done is train this model to play the noise of birds whenever he's in the camera, but it's got no other data, so it doesn't have any other best guess. Even if I stand there, it doesn't know what else to say. So all it's saying is that there are birds there. So what we need to do is make this better. We need to give it some more data. So that's why I need another volunteer. Anyone? Someone without a beard this time? Come on. What's your name?
Mike.
Mike. Mike?
Yeah.
Right. So now I'm going to teach the computer to play a guitar noise when Mike's in the camera. Go on. Try not to get too close this time. I know there's not much room, but...
Yeah.
So we're going to take some photos of Mike. There we go. Now Mike's there, we've got a guitar noise.
Yeah.
I mean, when he's gone, it's sort of thinking, well, it's this guy. So Paul. Phil. Sorry, I'm bad with names. So, no one's there, it can't figure it out. It's playing a guitar now. Now if I get in the camera, I've got a beard, it thinks I'm Phil. But if I teach it, it's its best guess. Now if I teach it to play a trombone when I'm here, it's just got a bit smarter. And now it knows that I'm the trombone guy. Now Phil gets back in the camera. There we go, it knows it's Phil again. And that's all machine learning is. We're telling the computer to match patterns, basically, based on... I'm going to stop that now. Thanks guys, you can sit down. But that's what machine learning is. We're teaching the computer to match patterns, to recognise patterns based on the past data that it's been given. And then from there, it's going to try and predict what the new data is. That's basic premise. And that was all in the browser, right? That was all using JavaScript. That's libraries provided by Google, used by Google. So imagine what we could do if we started harnessing the cloud, like Azure, AWS, all the big data platforms that they're providing us. We can start doing some really cool stuff. And these cloud service providers, they want us to do it. They're starting to create big data frameworks for us to use so we can clean the data better, we can transform the data into a format that we can use, and then so we can train predictive models to actually create machine learning solutions and use them in our products or our websites or whatever we have. And the point I'm trying to make is that you guys can now consume these things, and it's not hard, and we can start using machine learning. So, hands up if anyone already utilises machine learning. Yeah? A few people aren't putting their hands up. How many of you guys use Netflix? Yeah? How many of you guys have ever applied for a credit card or a mortgage, or have ever been to a supermarket? No? No? Okay. All these places use machine learning to provide you a service, and you might not even know about it. The point is, machine learning is used everywhere, more than we even realise. It's ubiquitous, and knowing about it makes you valuable, makes your business better. If you're a business owner, if you're a decision maker at a business, you can start to harness machine learning, and you can improve your business. I'll give you some examples of things that are already doing this. So, fraud detection. We need to find out if your transactions are naughty hackers or if they're genuine. So, machine learning does that. Supermarkets, figuring out how much fresh food we need to buy, which, as you might not have realised, is a big problem, because if we buy too many strawberries, no one's going to buy all of them. Amazon, e-commerce in general, all these things use machine learning. Items related to what you viewed. It's not just a simple table scan based on other people's orders. It's machine learning. Items to explore, it's machine learning. I bought one PS4 game and it thinks I've got a PS4. It's not always greatly accurate, but that's my girlfriend. It's not my alter ego. Yeah. Even Tinder uses ML. Right. That's Gabs. It's not a fad either. The trend is not gone too far. Sorry, Gabs. It's not a fad. The trend is not slowing down, and the value is real. So as developers, which I assume most of us are in the room, we need to upskill, and we need to start learning about machine learning and using it, because people want us to use it, and there's a shortage of skills. So if we don't start using it, someone else will. If you start harnessing ML, you make yourself more employable, more valuable to your current employer. So I've told you why you should care about machine learning, but what is machine learning? It definitely falls under the broad buzzword of data science, whatever that is. And these are some other buzzwords which you might have heard: data mining, predictive analytics, machine learning, big data, data visualization. Some of these are regularly conflated with machine learning. Some of them are completely different, but a lot of them overlap. And so knowing about one of them might mean that you know about another one, which is good. But we need to have a definition of machine learning to continue, so this is it. Machine learning allows computers to learn from data without being explicitly programmed. So as we saw in the example with the guitars and stuff, I didn't tell it to play a guitar noise. Well, I did, but I didn't program it to play a guitar noise. You know, when I'm there, it figured out based on the past snapshots that were taken that that's when. Well, sorry, it was you, wasn't it? That's when Mike was in the camera, and so that's when they should play guitar noise. So that's the distinction. If you take out the computer part, that's just learning. Anyone can spot, any human can spot patterns in data, be it a book or a spreadsheet, and then predict what's going to happen next. But the point is that computers are doing it, and we're not telling them what exactly to do. We're just sort of telling them, give us something that's useful. Okay? So, I'm going to whiz you through some concepts, and then we're going to get onto the problem of the day. The first thing we need to talk about are the different types of machine learning, and there are sort of three, maybe a bit more. I'll talk about three today. The first one is supervised machine learning. This is what most people will imagine or talk about when they're talking about machine learning. And the idea is we give the model, we train a model with some data. Imagine it's credit card data to develop a fraud detection model. Sorry, not a fraud detection model, a credit scoring model. So we've got a bunch of people's information. We've got all the data for people that have good credit history and all the data for people that have bad credit history. And what we want to do is we want to figure out if when the next person comes along, they've got a good credit rating or a bad credit rating. Because what we want to know is, shall we give them some money? Are they going to pay us back? And as you can imagine, that's extremely valuable to people that dish out loans, because they don't want to give out money to somebody that's not going to pay them back. How do they know? You know what I mean? It's hard. That's what supervised machine learning is. You create a model and you ask it a question next. The other main type of machine learning is unsupervised machine learning. Now, this is more of an exploratory step. And what it does is, what it is you don't really know what you're trying to get out of the data, but you know that something's there. There's a pattern somewhere, not quite sure what it is, but I know that there's something there and there's going to be some value eventually. So you're just going to pour your data into an unsupervised machine learning algorithm, and it's going to start to group the data based on different properties, and it might find similarities between different groups and segments of the data. And then that's down to you to go into it and have a further look and try and think what the next step might be to get some value out of your data. I'm going to show you another example, obviously again by Google. This one is the infinite drum machine. So what Google have done here is they've compiled a massive list of different noises, any noise that you might think of, like somebody dropping a pencil, somebody beeping a car, and they've just plumbed them into this model, and they've grouped them based on what they sound like. So let's try and zoom in a bit. Wrong way. So we've got the noise of a glass bottle. Oh, I've muted it. Oh. So I'm going to turn down a bit more. All these noises sort of sound similar. They're not massively different. One's a toaster for some reason, one's a lawn tractor. If we go over here, you know, and Google, the people at Google haven't spent hours and hours putting these next to each other on a graph. They've just put it, you know, that would be boring. They've just put it all into this algorithm. It's my favourite bit, the whistles. These are all the different types of whistles that Google have recorded. What I'm trying to demonstrate there is that's what unsupervised machine learning is. Obviously, that might not be useful. It might be if you're a sound person, I don't know. But they might then look into it a bit further and try and figure out what they can do with those groupings. And I don't know why it looks like a human brain. I don't know if it's done that on purpose. That's unsupervised machine learning. There's one more type I'm going to talk about. That's reinforcement learning. Now, the only reason I'm mentioning this is because machine learning is a broad topic, and not all of the problems or all of the solutions that you get in machine learning fit firmly into the category of either unsupervised or supervised. There are other algorithms out there that sort of do other things, like a reinforcement learning algorithm gets rewarded based on its predictions and then tries to maximize its own reward. And the reality is that in a real life scenario, the problem is probably going to span both supervised and unsupervised algorithms, and so is the solution. So it's not a case of when you've got your machine learning problem, you say, right, first step, is it supervised or not? Because you're probably going to do both in a real world scenario. It's never clear cut. It's reinforcement. So the problem, I know that the talk is about house prices, so I want you to all imagine a hypothetical scenario where Kev has come up to me and said, this property stuff is easy, I bet I can do it right well, make me some machine learning. So Kev's starting up his own property selling website called littlekevmove.co.uk, and he wants me to make it better. So what we're going to do as we solve this problem together is follow the machine learning workflow. This is not something that I've made up. This is sort of like the industry standard workflow that you would use as somebody that's doing machine learning. And it's been developed over many, many years, because machine learning isn't new. It's been around since the 50s and 60s. And it's just a methodology of how to solve your real-world machine learning problems. So there are 4 main steps. And the first step is defining the question, because Kev, as a business owner, has come up to me and said, make me some ML, but what are we trying to do, right? He's going to give me some data, about houses, how many windows it has, how many driveways it has, if it's in Kinborough, if it's in the manor, and we're going to try and, get some value out of this data. So, can anyone think of any valuable questions that we might ask of that sort of data set? No? Predicting its house price is the obvious one. I mean, there are others, like predicting how quick it might sell, how long has it been on the market, that sort of thing. The houses in a certain area sell faster than others. So it's not always obvious, but the main point is that we need to know before we carry on this workflow what we're trying to find out. It's not just a mad gamble. We want to know where we're going. And importantly, what we need to know is how we will know when we've got there. What is success? When you get a spec, when you're writing software, you know what the end result's going to be, and we need to know what that is, even in machine learning. So what we're going to do is create a solution statement. And the solution statement is create a model which can predict the selling price of a property with at least 80% accuracy. And it's that last bit that is the important bit, with at least 80% accuracy, because no model is going to be 100% accurate, but we need to know that Kev's happy, and Kev's told me that it's 80%. So we're going to go with that. The next step is preparing the data. Now this is by far the hardest part of any machine learning problem, and this is going to take up probably around 70% of the time that you spend doing it. First we've got to get the data. Luckily for us today, Kev's provided us a clean data set, but it might be that you have to pull in data from multiple data sources. You might have to get some from SQL, some from Google Analytics, some from wherever. It's not always going to be nice. For starters, you might not even know what it looks like. You have to spend time looking at it. Then you need to make it all flat and denormalized. You need to get it into a way that a machine learning algorithm can ask this question of it. We need to get rid of any bad rows, any rows that don't make any sense, any columns that are useless to us. We might add more columns that make it easy for the algorithm to use, like create some Boolean fields rather than some weird enumerations, which we'll go into later. And that's hard. We're going to do that, and we're going to do it again, and then we're going to look at the result, and we're going to do it again. And we're not going to do that today, but that is what you would do. After that is the good stuff. We're going to create the model. So we need to choose the algorithm that we're going to use, of which there are many. We're going to train a model with the data that we've just prepared. And then we're going to look at the model that we've just created. We're going to test it. And then we're going to ask ourselves, is this good enough? Is it over 80%? If it is, do we stop? Or do we try and make a better one? Have we got enough time? Is it crap? So we're going to do that again and again and again, and we're going to create more and more models, and we're going to tweak how we use the same algorithm multiple times. Once we've done that, we need to deploy the model somewhere. So we've created a predictive model for Kev, but Kev wants to be able to use it on littlekevmove.com, right? There's no point in having a model out there that I can run on my machine that the website can't. So we need to get it somewhere that it can be consumed. So that's machine learning workflow. And now it's time for the demo. So is everyone accustomed with Azure? Is anyone not accustomed with Azure? Have you used other cloud platforms? Yeah. So you get the idea. I've got an Azure account. That's all that I've done so far. I've created an Azure account. Next, I need to create let's type in machine learning. And Azure's helpfully created this little thingy for us, Machine Learning Studio Workspace, and that's where all the magic is going to happen today. So we're going to create that. They do cost, but it's not very much. You can spin them up and tear them down whenever you want as well. So we're going to call this Little Kev Move. Yeah. I've already used my free one, so you do get one free one, but I'm going to have to spin up a costly one. As you can see, it's creating us the workspace itself. It's creating us a storage account, which is where all the data is going to be stored, and it's where our experiments are going to be stored as well. And it's also creating us a web service plan. Now we're going to come into this in a bit more detail later on, but essentially that's where we're going to host the predictive models when we've created them. Has anyone used an app service plan before? Or it's sort of like just a server, basically. You have? It's a server. So that's that. Now whilst that spins up, Kev has just sent me the data. So we're gonna, I hope you don't mind, but I've not told Kev about this. So this looks horrible, I know, because it's one massive CSV file, but this is the sort of thing that you'll be doing when you do your machine learning solutions. And we're on to the second step of the workflow. We're going to prepare the data. So what we need to do is get used to it. And I'm not going to do this for too long because it wastes your time, but we're going to have to look through this. And luckily for us, it's quite a clean data set. But as you can see, some of it makes no sense. I mean, well, BLDG type, building type, I guess. But we've never seen this before. 1 fam, 2 FM con, we don't know what that means. Neighbourhood, Vinca, does anyone know what Vinca is? No? So that's representative of what might happen. You might not know what you're looking at, and that's the hardest bit. Luckily, Kev sent us a data description file as well, and this is just as horrible because it's explaining what the data is, but no one wants to read through this. Let's be honest, it's horrible. But there's a lot of value in there, and so this is a detailed description of every field, or what they might call a variable in machine learning, that we've got in the data set. And what this is actually a good representation of is, as a web developer or a software developer that's using enums in their database, this is the sort of stuff you're going to get. You're going to get 1, 2, 3, 4, 5, and you're going to have to figure out what it is. But the data scientist or the person that's creating this machine learning model, they're not going to know what 1, 2, 3, 4, 5 means in that context. So you've got to try and figure it out, and you've got to do some transformation on the data to make it happen. Now we're going to jump into our machine learning studio workspace. If it appears. So it's created it for us, and we just click onto it and we click Launch Machine Learning Studio. That's it. And for some reason it thinks I'm not signed in. That is the wrong one. Right, so here we are. This is the workspace, and it's completely empty. So we've got this thing called experiments, which we're about to create. We've got trained models, which we're about to create, and we've got data sets. So this can connect to a database, it can connect to storage accounts in Azure, that sort of thing, but we've got a CSV file today, so we're just going to upload it into our workspace and then play around with that. There it is. I'm going to call it housing data. Well, that's annoying. Tell you what, I'm just going to jump into my other workspace because it's not created it right for some reason. So as you can see, when I was practicing, I've already uploaded it. I don't know why that ever happened. It doesn't usually. So we've uploaded our CSV file. The next thing we need to do is we need to come in here. We need to start our experiment. So this is it. This is the studio. And it is drag and drop, which makes it very nice and easy to do this stuff because it's a lot more complicated when you're writing R and Python. So on the left-hand side here, we've got modules, and these are the things that you drag and drop and you connect them together, and it knows how to flow the data around, and these represent different steps in the process, like cleaning the data or transforming the data, splitting the data into different data sets, these also represent things like the algorithms and the parameters that you're setting on them, and they help you evaluate the algorithms and the predictive models as well. So what we need to do is get our open save datasets. We need to drag in our data that we've just uploaded. So there we go. We've got the start of the experiment. And as you can see, it's got an output here. Each module might have inputs at the top and outputs at the bottom. What we can do is we can drag the output onto the next module. But first what we're going to do is we're going to right click here and click visualize. Now, similar screen, looks a bit like Excel, but it's a lot nicer. It's more spread out. Still got all the horrible columns, but we can click onto each one, and we've just got some insight into the data that's in that column. We can see that, for example, the land contour for pretty much all the properties in the data set is level, and then some of them have banking, some of them have other things. But it's just a nice way to inspect our data, because we're supposed to be creating a predictive model for this data set, but we don't know anything about it right now, so we need to spend time exploring it. And that's one thing that Machine Learning Studio is good at. So once you've spent time looking through it, which we're not going to do, we might decide that we want to clean it. Now what we have got are a lot of data transformation modules down here. We can filter the data, we can manipulate the data, we can add more columns, more rows. We might want to get some more data and merge it in, or we might want to just get rid of half the data because it's crap. I'm not going to spend a lot of time doing that today. What I'm going to do is throw in an R module. You can also throw in Python modules if anyone prefers Python, but R and Python are the go-to languages for machine learning these days. You can do pretty much anything you want in both of them. I'm not going to dictate which one's better, but essentially we can just drag this module in there, pipe the data set into that module, and the data set will be transformed however we want to in this R script. Now, you don't need to know R to understand this. We've basically got a data set input. You can have up to 3. We're only going to have 1 today. You can do whatever you want with it using R, and then you output the data set right at the end. I have already created an R script that does allow data preparation, because trying to do all that in one demo would be a waste of everyone's time. And I did pull this off of an example on the internet, and if anyone wants to, I'll show them where it is. We're transforming a lot of those columns that were enumerated columns with a lot of different values, where most of them were 1, like the paved example. The land contour, a lot of them were flat, and hardly any weren't flat. So, where is it? Level, that's it. We basically transformed it into a Boolean field. Is it level, true or false, 1 or 0? We've done that for a lot of the columns. It just makes the data easier to read as a human and more effective in the algorithms. We've done a lot of that. So that's it, we've done one thing to it. We've transformed the data, and at the end of this script, we've got some data that we are comfortable using in our predictive models. So next what we need to do is run it. And now with the power of the cloud, Azure is going to run that script on the data set. It's not a massive data set, but you can imagine that if it was, it'd still perform pretty well and it wouldn't slow you down, because this is all in the cloud. It's not on your local machine. I mean, it's still taking 11 seconds to run. But when it finishes, we have some cleaned up data. Now if we look here in the unclean data, 81 columns. After we've transformed it, we've actually got 86. So we've created some more variables based on the value of other variables. And this is something that happens quite a lot in machine learning. You're trying to make the data more useful, easy to understand, and more effective in your algorithms. So there we go, we've got some clean data. Now we need to create some models. We're going to create a few models, we're going to tweak them, and we're going to do that because the first one's not going to be very good. And we're going to compare them all, and we're going to see how they perform. When you train a predictive model with this data set, imagine if I trained the model with all of the data set. How am I going to verify that it's worked afterwards? It's not going to work. It's not going to be able to, is it? Because the data that I use as input to train the model is obviously, well, the model's obviously going to be able to predict the values of those data pretty well because it was trained on them. So what you need to do is you need to split your data set into two. You can have half of it as training data and half of it as test data. You train your models on the training data set, and then once you've created your models, once you've got a model that you think might work, you test it with the test data set, and that ensures that the model isn't just saying, oh yeah, I can do that because I've already done it. I mean, it's looking at new data as far as it's concerned on the test set. So that's the next step that we need to perform. We need to split the data set. And again, that's pretty easy with Azure. We just have to get the split data. So there we go. We pipe the clean data into that. We tell it on the right hand side here how much, what the weighting is to split. So I'm going to go 0.7 on one side, 0.3 on the other. So there are two outputs. Output number one, we're going to use as training data. That's 70% of the data set. Output number two is our test data. Okay, and it doesn't have to be 70-30, but that's pretty standard. And next we need to train our model. We're going to train one model first. So you come down to machine learning. You find the train model, drag it in there. And all you do is drag your data set in there. But as you can see, it's expecting one more input. And that is an algorithm, because the train model thing just does a training of a model. We need to find an algorithm. We need to initialize the model with an algorithm. So, how many of you, who wants to suggest an algorithm to use?
The Bayesian model.
The Bayesian models. Anyone else? Does anyone know any, apart from that one? Right, that was the boat that I was in as well. Luckily for us, Azure, Microsoft, have provided us this very helpful tool. It's a cheat sheet. This will be your most useful tool when you're using Machine Learning Studio. These are all their algorithms that are available in Machine Learning Studio. I mean, and there are more algorithms than that. They don't have all of them in there, but they've got good implementations of all of these. And you start here, and you sort of go through it, and based on what you're trying to predict or train or whatever, you end up with an algorithm that might be useful, or it might not be. They're not going to do it all for us. So as you can see, we've got anomaly detection algorithms, we're not doing that. We've got clustering algorithms, we're not doing that. We're not predicting categories either, because the value we're trying to predict, a house price, it is continuous. It's not just 1 or 0. It's not good, bad, or ugly. It's any number. So we're not classifying the input either. What we're doing is regression. As you can see, there are 7 algorithms for regression training in Azure ML Studio. Now, not all of them are going to be good in our scenario, and I'm not going to suggest that we just train 7 models and then have a look. I mean, you could, but I can't be bothered. So we're going to look through and figure out which one. For example, data in rank ordered categories doesn't sound like what we're doing. So we're not going to do ordinal regression. There is Bayesian linear regression right there, like Kev said. But what I'm going to pick first is linear regression, which is generally the go-to one for regression models. You just do that straight away and see what happens. As you can see, it's good at fast training on a linear model. So what else do we need, right? Going to create as one of those. Where is it? Regression. There we go. Linear regression. So you drag that in there, and that's the other input for the train model module, and it just tells it which algorithm to use. And as you can see on the right hand side here, we've got a bunch of other parameters that we can supply to the algorithm. We're just going to leave them as the standard ones for now. Once we've trained our model, we need to decide if it's good or not. And to do that, Azure has given us two very useful modules. The first one is the score model module. So we take the output of the train model module, which is a trained model, we put it into the score model, and then this is when we get our test data, which is the other 30% that we've not touched yet, and we drag that into the score model. And essentially what that will do, is it'll use the input, the test data set that we're giving to the score model module, and it'll not look at it won't look at the sale price column, but it'll, based on all the other columns, using the predictive model that we've just trained, it'll try and figure out it'll try and predict what the house price is for that row. And then, obviously, then it will look at the answer, and it'll figure out how far off it was. And that's it, that's how we see if we've done good or not. Up here, and that is the evaluate model module. And what this does is it takes the scored data set and it creates some sort of industry standard metrics that people tend to use a lot to figure out if models are good or not. Yeah. Train model is still complaining because we're not told it which column we're actually trying to predict, so it doesn't know how to train it. So I'm just going to tell it to train the sale price column. There we go. And it's as simple as that. We've just created our first predictive model to predict the price of a house, and then we've scored it, and we're going to evaluate it in a sec. We're going to have a look, see how good it is. So it does have a habit of trying to do everything again, annoyingly sometimes. Sometimes it doesn't. I've not figured out why, but you can see where it's getting through. So it's trained the model right now. It's scored the model, and we're about to get some metrics out of it.
How many rows are there in the data set? How big is it?
There are, I think they're about 1,400. I'll have a look now. So we're going to visualize the scored data set. And as you can see, this is very similar to, sorry, that's the test data, that's 30% of the data. So 30% of the data is 438 rows. This is the test data set. All we've done is right at the end, added on another column, that's the scored label. So this is the predicted house price, predicted sale price of each row. Sometimes it's not got one. I think that probably means it's not a very good model. As you can see, not very useful for us because we don't want to go through it all and look at it. So that's why I've got the evaluate model module. When we visualize the output for this, we've got some very useful data. We've got all these metrics here, which are sort of standard ones which you might use to compare any module, any predictive model. And we've got a histogram, which I'm not going to go into. The metric, I'm not going to go into all the metrics because it's not a stats lesson. The one I'm going to look at is the coefficient of determination. And the coefficient of determination, what it does is it tries to describe how good a fit the predictive model, the predictive model that you've trained is on the data set that you've created, where 1 is a perfect fit and is predicting it completely accurate every time, and 0 is crap and we don't want to use it. So as you can see, we've got 0.6 here, which is pretty good, because when I practiced it, I got -4, minus 0.4. When I practiced it, I actually only split the data 50-50. Now I've done it 70-30, so it's actually improved it a lot, just giving it a bit more data to train. The more data, the better. You know, we've trained it on 1,400 observations of different housing prices, but that's not very many. There are a lot more houses than that, and if we wanted a good model for little Kevin with UK, then we need to provide a lot more data for it. Yeah. Just by the way, a negative coefficient of determination would mean that it's basically really bad. Yeah, don't use it. It's worse than trying to guess. But we're not going to stop there, because Kev wants an 80% precision, unfortunately. So we're going to go back to the cheat sheet and we're going to pick another one. Does anyone else want to suggest one this time? I mean, Kev, you said Bayesian. Do you want to do that one? Yeah? Yeah. Bayesian linear regression. It's a linear model, good on small data sets, which sounds pretty good for us because we have a small data set. Let's try that. So again, we're going to do all this bit again. All we're going to do is give it a different algorithm. We've done all the hard stuff now. I'm just going to copy and paste that. I'm going to go down to the algorithms. Oh, it's up here. I'm going to drag that into the model. And what you can do, let's just delete that, is you can actually score 2 models and then compare them against each other. That's what we're going to do right now. I'm going to run this again. Oh. Yeah, see, I'm not giving it the training data set and I've not given it the test data set either, but it's told me, so that's good. And I need to tell it which column. Oh, it's got it. Yeah, that's because I copied it. So we're going to run those ones. When that's done, we can directly compare how the first model and the second model performed. So that's done. We can evaluate those results. Right, so the top one is the linear regression model that we did the first time. The second one is the Bayesian one, which Kev suggested. It is performing better because it's 0.75 coefficient of determination. Yeah. So we've created two predictive models. We're going to create another one, and then we'll pick which one we're going to use in our application. Anyone else got a suggestion? Shall I just pick one?
Decision forest.
Yeah. Accuracy and fast training sounds good. The other one down here is, you see it? Boosted decision to regression. Accuracy and fast training, but it's got a large memory footprint, which probably doesn't matter for us right now, but maybe it would if we had a massive data set. And that's another thing you've got to consider when you're doing machine learning. The algorithms do have an impact on computing power, and if you're trying to save money or time, then you need to consider that as well when you're creating a model. So we're going to go for decision forest. And again, I'm just going to copy and paste. It's not letting me. So I'll drag in the training data and the test data. And I suppose if we really want to, we can compare. For some reason you can only compare 2 at a time. I'm not sure why. It's quite annoying, but I suppose we need 3 if we want to compare each of the others. So I'm going to do this. Yeah. So there we go. We're going to create another model and see how it performs. So we've got 3 models now, and we're going to compare all of them. And right at the end is the last one. Forgot what it's called, but yeah, 0.83. So it looks like that's our candidate. That was the decision forest. And I know I've got them all compared to each other, but the values are the same in each one. So yeah, one was 0.6. We're not going to use that. I think Kev's going to get pizza. Oops, shit. Is Kev going to get pizza? Yeah. Yeah. So I'll stop there for this first part. After the pizza, we're going to deploy this into the wild and consume it in an application. So we're starting to get back into the realm of software developers, somewhere that most of us are more comfortable at. But I hope what you can take from that is that you really can just spin up Azure ML Studio and make something that's half decent and start using it. Because you don't have to make the best predictive model in the world to say that you've done some ML and use it in your application. It's probably still going to be better than if you tried to do some funky logic with Link. What we're going to do is, we've just created a predictive model. We're going to deploy this as a web service. I'm going to show you how that works, all the great possibilities that it opens. And then we're going to consume that web service in just an application that I've already made, just to show how easy it is. So, if you remember from before, I think the model that turned out best was the decision forest. Yeah, 0.83. So, as I was saying to some people during the break, in real life, if we had more than an hour and a half, we wouldn't just pick this one because it says 0.83. We'd spend a bit of time looking at all of them, understanding what's actually going on, and making an informed decision. But for today's purposes, we're just going to pick the decision forest regression model and deploy that onto the internet. So Azure ML Studio makes that very easy. All you have to do is select the model that you've trained, which is this one. Just click onto it, and then you go down here and you click set up predictive web service, and it does all the hard work for you. It creates you another experiment up here in the tabs. We had a training experiment before. Now we're on to a predictive experiment. And what it's done is it's simplified massively the workflow that we had before. It's got rid of all the models that we're not using, and it's condensed the predictive model that we have trained just into this one module here called, well, it's named it after the title of the experiment, which I've not saved yet, so it's saved it as experiment created on the 11th. So it's still got this input data set here, but it's sort of greyed out, and that's just sort of trying to represent where that would have gone if you were doing your experiment, but now we're getting the input from the web service, and so it's going into the same place by default. However, we don't want to receive input like that, because Kev's given me the requirement that he's assured me that the contract for this API that we're about to create is going to use data that's of the same format as that after we cleaned it. So we don't want 81 columns, we want 86. That's just something that you can do, so I'm just doing that to demonstrate that. Obviously, at this point, you could add more modules if you wanted to, and you could transform the data that you receive from the web service in a different manner to that which you trained with, if you wanted to. But what I'm going to do is I'm going to delete this line here if I can get it. No, can't get it. It's very annoying. I'm going to drag this onto here first. There we go, that's it. So the input I get from the web service, it's not being cleaned by the R scripts which we created before. It's just going straight into the model. And then it just follows through the model after we've scored it, which is in essence predicting the value of the house. It comes through the output, which I'll show you in a sec. So I'm just going to run it all to make sure it works, because we have to. I'm struggling without a mouse. So that all worked fine. Now we can deploy the web service. We've got two options. I'm going to pick the new one, which is in preview. It's been in preview for about 2 years though. So deploy web service. So opens a new tab. And now we're in a new place entirely. We're in the web services portal, or whatever you want to call it. So we're going to give it a name, and we're going to call it Little Kev Move. I'm going to give it a storage account, which we've already chosen. I'm going to put it on the Little Kev Move plan, which we created earlier on in this demonstration. The one where I picked S1. You can give it different amounts of server, like computing power and stuff, depending on how much you think it's going to go through it and stuff, how big the data set is. Because it's not like that, it's more like that. You know, it takes a bit of time. And that's it, really. We just deploy it. And now what it's doing is creating a HTTP API, which we can access with an API key, which we'll be given in a second. And as you all know, you can consume a HTTP API in any language that you want. So here we are. We are onto the sort of dashboard area for that web service. Now the first thing I'm going to take you to is this, the Swagger API, which you probably weren't expecting, but I'm sure, has everyone seen Swagger before? Has anyone? Some of you might not have seen it. It's a standard approach to, it's like a developer interface for explaining the contract of an API so that you can integrate with this application in your applications. So it tells you the request body that it expects, and it tells you the result that you're going to get after you've performed that request. So as you can I think that was that table. Anyway, as you can see, the input that it expects is just one row, well, or many. As you can see, it is a collection. But each one is just an object which is of the exact same structure as the data set after we'd cleaned it. So there's going to be 86 things here, which is a lot, but that's what we need. And the output is that same collection of objects that we gave with a few extra, well, 2 extra properties at the end. This one, which is useless to us, and it's not useless to us. This one's, we don't care about that one. The score label mean, I don't know why it's called that, but that is a prediction that we're going to get. And I'll demonstrate this up here and go to, well, first we need to configure it to enable sample data. And here we get the API key that we can use to access this web service. And I'm just enabling sample data. And all that does is, on the next tab that I'm about to show you, in the consume tab, it's going to pre-populate a form with some sample data from the training data set, just to make it easier for us to test it. So once that's loaded, I'm going to go into consume test. So it's provided as a form based on the input that it expects, and right down the bottom I can hit send, and it'll give me the output here. And when I enabled test data, all I did was allow it to access the test data set and to pre-populate the form to make it easy for us to test. So if I come all the way down here and press test, this is sent a request, and for that input the predicted house price was 205 grand and a bit more, which isn't bad, I guess. Depends what market you're in. So that's it. We've got HTTP API. If you click onto consume, if you've not done this before, then you'll want to come onto here. It gives you a sample program, and it's nothing you won't expect. It's just giving you an object. If you keep going down, and then it's using HTTP to perform a request. And it's consuming somewhere. Yeah, so it's sort of, you put the API key in here, and I think most of you can see where this is going at this point. The important bit to note is that we've created a web service which is easy to consume. So what I'm going to do is whip out Visual Studio. I did create a really small web app which just basically has a form on it and allows you to consume this API. And I'll put this on GitHub if people want me to. But essentially, we are just going to send a request to this web service and use it. That's it, I put it to model in the wild. I'll show you this in action in 1 second. Here's one I made earlier, littlekevmove.co.uk. I couldn't resist actually buying the domain. So we've got 3 app settings. So we've got the subscription ID, which is your Azure subscription ID. We've got the web service ID. That's the ID of the web service which we just deployed. And this is all available in Azure. And then we've got the API key. And as you can see over here, we've got all that here, but primary key. If you're going to configure, you can actually change the API key if you so wanted to. There we are, littlekevmove.co.uk. It's Kev doing a run.
I feel like I'm being stuck.
I'm sorry. And it's simple as that. And at this point, it's your domain. You guys are the application programmers, more or less, and I hope you can see how this is going to fit into your products or the things that you manage. Yeah, that's our prediction. We've even got the predicted error, which means how far it roughly thinks it may be off. Another thing I'll just hint at, but not go into in too much detail, is that obviously that's one input. Yeah, that's HTTP request. If you, with one input in the collection, if you put a massive amount of objects in that collection, it might take a bit longer. It's going to get longer and longer and longer. At some point, it's going to time out, or you're not going to want to wait for it. Or maybe your application doesn't actually need it there and then, but it wants to do it overnight and it doesn't want to hang. You might want to put it in a scheduled task, whatever. So you can actually batch up requests. Now, I'm not going to go into this anymore, I'm just going to hint at it. But essentially what you do is you put all the data that you want to create a prediction for into somewhere that this web service can access. And from what I remember, it's in a Azure storage account, which is just a place where you can store things. That's all you need to know. And you tell it to go to that data set and it'll run it however long it takes. You can sort of tell it to run. If we go to Swagger API, you can see. So you submit a job, and you tell it where the data is stored, you tell it the connection strings and stuff. And then you tell it to start the job, and then you can sort of monitor what state the job's at. And obviously your application can keep pinging it, and later on it can figure out that the job's complete, and you can then look at the results, which is also stored in the same storage location which you put the input in. And then from that you can do what you want with it. So that's batch execution of data. Yeah. So, yeah, that is all I wanted to show you today. Hope you enjoyed it.